Okay, good afternoon. So today initially I will discuss on the calculation of centroid and moment of inertia. Centroid or center of mass, they are basically like centroid and center of mass are the same or different? क्या बोल रहे? Centroid and center of mass are the same? Are the same? Okay. Are the same or different? I have discussed this in detail in the class, and you can recall that if the density everywhere is same, if density everywhere is same, then the centroid and center of mass they are same. If the object having homogeneous density, density at all locations are same, then the centroid and center of mass are at the same point. Otherwise, they are different. Okay. Similarly, everywhere if the density and the acceleration due to gravity are homogeneous everywhere, then center of mass, centroid and center of gravity all are coincident points. If both the density as well as the acceleration due to gravity are constant everywhere on this body, then all three points are coincident. Okay. Otherwise, there will be differences. Okay. Now, one problem was there, like this one. You can have same length, okay, or maybe different. It will be given, but the calculation is similar. Say this is a this is a B, P, this is the section. Okay, so we are interested in calculating the centroid. Okay, centroid and center of mass they will be coincident if it is homogeneous. Okay. Object is given. Determine the centroid. Regarding solution. Okay. So determine the centroid. Now we are uh, assigning the the coordinates reference frame as this is x and this is y. We have to determine the location of the centroid. Okay. So I know that we will always start from the definition. Okay, the definition of centroid. So what is that? Xc is equal to integral x dA divided by integral dA. A is an elemental area. dA is equal to elemental area. Elemental area. Now, you see that if I take some elemental area, like say this, so there will be limit of integration applies. So x variation dA for this, what will be the variation over the whole area, over the whole area. Clear? So whole area means this whole area. Okay. So whole area is this one. Clear? Now this for this, if I try to determine some elemental area dA, say for example here I take E. This is the elemental area, say dA. What is that? dA. Some x length multiplied by dy. So this is what dy. dy. This is dy, small dy, and this is say x, some x. Okay, some x. Okay. Now, this x is constant for this. This x length is constant for this element, for this length, for this side. But when I come here, that will change. Okay. So what should I do? I can write that for y from 0 to t, this is x. That means for this y, for y is equal to 0 to t. Y is equal to 0 to x is equal to a. That x is a. Because dA is x, some x dA. This x and this x are different, so I will I will means in general they are different. So I will write say some x x prime. Okay, x prime. Say for example, some x prime. Okay, some x prime is the length of the element, and width of the element is dy. Huh? X prime into dy. This is the rectangle. Okay, from for y is equal to 0 to t, that x value x prime is constant is equal to a. This is constant. Again, for y is equal to t to t to a. Here y is equal to t, here y is equal to a. So y is equal to t to a. X prime is another constant value. What is that? This one, t. Okay. So if I try to expand this, what will be? It will be clear immediately. X is what? X is what? This x is what? This x is the centroid of this element. This x here, x is the centroidal x coordinate of the element. If I write this in a different form, it will be x dA from the whole area is equal to xc dA. What is the meaning? X dA, x d. But here the whole is within the integration, and this is the area. So for area, this is the x and centroidal coordinate, and this is the centroidal coordinate for whole. So you have to understand. So xc is the centroidal coordinate of the whole area, and x is the centroidal coordinate of the small area. So as if we are taking the small area and we are locating the centroidal coordinate, getting the product, sum it, and we get the centroidal coordinate multiplied by the whole area. So this is called the moment of area. This is called the moment of area because this is the area and this is the length, which is the arm of the moment. So moment of area, we have learned moment of a force. So it is kind of moment of area. We call it first moment of area. We have moment of inertia, so that is first moment of area. Then we have second moment of area. So second moment of area we call moment of inertia in general, right? So it's clear? Is the logic? This is the centroidal coordinate of this dA. This is the centroidal coordinate of this. This is what? This is A basically. So as if this is xc into A. So this is centroidal coordinate of small area. This is the centroidal coordinate of whole area. So when I take small strips and add them, the product of the centroidal coordinate of that and this, then I add, then I get the product. Now I know this, I will divide this with this, then I will get the centroidal coordinate of the whole area. Clear? So here also. So this is centroidal coordinate of this. Therefore, what is x? Therefore, x is what? If this is x prime, then x is for this length. What is the centroid of this length? If this is x prime, where is the centroid? Midpoint. What is that therefore? X prime by 2. So x will be x prime by 2. Clear? So it will be x prime by 2. So it is x and right, and then I will replace. So dA, what is dA? X prime into dy. dy. Now you see that initially the variable of integration was a, so I had a limit on a, limit of a. Now the variable of integration is y, then I will have a limit on y. যেটা ভেরিয়েবল হবে সেটা লিমিট নেব, সেইটা অ্যাকর্ডিংলি লিমিট করতে হবে।
ds1 xs into dy is না
হ্যাঁ
ds1 xs into dy
হ্যাঁ এই তো বসে দিলাম। Just okay. Now area was the integration variable. So limit was on a. Now the integration variable is y. So variable will be on y. So what is the limit of y? 0 to a. 0 to a. So it is 0 to a. Clear? So at the bottom you have x prime dy. Similarly it will be 0 to a. Clear? Okay. Now what I can do is, since you see that I have two limits of y, 0 to t and then t to a, so I will split these limits. So I will, this is the whole area. I know. So I will write 0 to a x prime dy is equal to, this is a, total area. What is that? 0 to t x prime dy plus t to a x prime dy. Isn't it? Clear? All over. Okay, is it clear? So I can split the limit. Now what is this? 0 to t. For y is equal to 0 to t, x prime is a. So it is a dy. 0 to t plus for t to a, it is x prime. So t to a, it is x prime kota t dy. It is how much? What is that? 0 t to a. Right? This is area. The calculation with you. So what is that? A dy means a into t. Limit nile a into t minus 0. A into t minus 0. Integrate করলে plus if I integrate this t into a minus t, right? So what is that? 80 plus 80 minus t square, right? কত হচ্ছে 280 minus t square. 280 minus t square. This is the area. This is A. This is A. So this is A into this area is how much? 80. This area is কত? 80. এটা কি দুবার নেওয়া হয়ে গেছে? কত এটা? এটা কত? এরিয়া? t square. T square. So 280 minus t square. ইন্টিগ্রেট করতে লাগবে না, যদি সিম্পলি করে নিয়ে করো যেটা হয়ে যাবে। হ্যাঁ তাহলে ঠিক নষ্ট হয়ে যাবে। ওকে এভাবে করতে পারো, তার মানে এটাকে করতে পারো। পুরোটা কত? পুরোটা কত? a স্কয়ার, পুরোটা স্কয়ার মাইনাস এটা কত? মাইনাস a মাইনাস t হোল স্কয়ার, a স্কয়ার মাইনাস a স্কয়ার মাইনাস 2at প্লাস t স্কয়ার, a স্কয়ার কেটে যাবে 2at minus t square. Anyways, you can show. Okay. Now, therefore, this is a. I will write immediately. Okay. Now, on the top, what will I do is I will write 0 to t. Another is t to a. What was there? It was x prime. I'm sorry. X into x prime dy plus x into x prime dy, both. Now you see that this is for what? This is for this area. 0 to b is for this area, and this is for this area. So what I can do is, instead of this I can split this, just to show that this is for this and this is for this, now divided by the whole area. So if I know the centroid of this and if I know the centroid of this, I can immediately calculate without integration. I will show it, I will show that, but with integration I am showing how that comes. What is this? One area is 2at minus t square. Now what is this? X integration 0 to t. X is how much? X prime by 2. X is x prime by 2. This x centroidal coordinate is x prime by 2. So it is x prime square by 2. X prime will be therefore x prime square by 2 dy. Minus this one, a plus it of type x prime, so x prime square by 2 dy. 0 to I'm sorry t to a, right? So what is that? 1 by 2at minus t square. What is this? dy. Sorry, for this, what is x prime? 0 to t. For that, x prime is a square. So it will be a square. So a square by 2 dy. Under integration, it will be t minus 0. Right? When I integrate dy, it will be y. Under integration, it will be t minus 0. Minus plus x prime square by 2. What is the x prime? T square. So t square by 2, because x prime is t, and here dy t minus t as earlier, t minus t, because the limit, it is basically limit means y2 minus y1. So y2 minus y1. So a minus t. কত হবে? minus t square, a square t by 2, a square, sorry, a square t by 2, a t square by 2, a t into a plus t by 2, তাই না? তাই তো? a square t by 2 plus t square a by 2, so it common নিলে a plus t by 2, another হচ্ছে minus t cube by 3 t2 by 2 তাই তো okay so it should come so এখানে একটা t আছে এটা t টাকে কাট করি তাহলে এটা t হয়ে যাবে এটা t স্কয়ার আর এটাকে 2 টাকে কাট করি ঠিক আছে তো t by 2 into 280 minus t square আর এটা এখানে মাইনাস তাই তো এটা হচ্ছে x কোঅর্ডিনেট x কোঅর্ডিনেট তাহলে কোথায় হবে এটা কোথায় এটা হবে এখানে y কোঅর্ডিনেট কোথায় হবে y কোঅর্ডিনেট কি বার করতে হবে it is symmetrical object তো y কোঅর্ডিনেট এক ডিসটেন্স আছে কিছুই হবে না আর কিছু হবে y কোঅর্ডিনেট একই ডিসটেন্স বিকজ দিস ইজ symmetrical in the x direction and y direction এটা একই পয়েন্ট
তাহলে সেন্টার অফ মাস সেন্টার একই
আবার সেন্টার অফ মাস
সেন্টার অফ মাস
what is the question determine the centroid to determine centroid
সেন্টার অফ মাস
সেটা মাত্র একই ওখানে it will be there itself clear it will be there itself centroid and centromers they are coincident যদি homogeneous হয় বুঝতে পারছি না আমি কি বললাম একই লাইনে x direction the distribution of area and y direction the distribution of area they are symmetrical so that if I determine the x coordinate I need not determine y coordinate I need not determine what y coordinate I will get the same equation only I have to go for wasting time in solution if this is known then this is also known only thing if these are different then I will replace for example in this direction you have a in this direction you have b so I will replace the corresponding terms then I will get it so engineers need to wisely do things need not repeat the same thing we will not repeat clear so whatever is done is y coordinate is same so what is the y coordinate same thing clear centroid is center of mass itself for this center of mass and centroid are coincident points if nothing is mentioned center of mass and center of centroid are coincident points কেমন ক্লিয়ার হলো তাই তো কি হবে কোইন্সিডেন্ট হবে তো
সেন্টার অফ মাস না বলে সেন্টার অফ প্রপার্টি সেন্টার অফ সেন্টার অফ মাস তো সেন্টার বাদ করলে সেন্টার অফ মাস
হ্যাঁ
সেটাই ডক্টর ইউজ করলেন সেন্টার অফ তারা
প্রশ্নটা বুঝতে পারবেন ওকে এনিওয়েজ so now what we will do is instead of this solution what we will do is we will apply the simple knowledge. I know, say for example, what is the, if you have an area, if you have an area, like say this is a base and this is a height, what is the centroid of this? এই তো মুশকিল মুখস্থ করলে সমস্যা হয়ে যায়। সেন্ট্রাল মাস বলছি আমি, মৌলিক বিন্যাসে বলছি না। সেন্ট্রয়েড অফ মাস, এই পরীক্ষার সময় মাথা ঠান্ডা রাখবে, সব জানলে অনেক সময় অসুবিধা হয়ে যায়, ঠিক আছে? সব জানলে অসুবিধা হয়ে যায়। আমাদের সবই আছে, হ্যাঁ, আমাকে আমি ধরো হয়ে গেছে আমার মাস্টার ডিগ্রি, ঠিক আছে, আমাকে চেয়েছে মাস্টার ডিগ্রি সার্টিফিকেট, মানে মাধ্যমিকের সার্টিফিকেট, মাস্টার ডিগ্রি সার্টিফিকেট দিয়েছে, গোলমাল হয়ে যাচ্ছে। সেজন্য মাথা ঠান্ডা রাখতে হবে, পরীক্ষা কিন্তু সিলি মিস্টেক হয়ে যায়, নলেজ মানে গোলমাল, আমারই গোলমাল হয়েছে কতবার, সেজন্য মাথা ঠান্ডা রাখতে হবে, ঠিক আছে? ক্লিয়ার? What is the centroid? Centroid কোথায় আছে? এখানে হবে, বি হলে বিতে হবে, বিতে বি বাই 2 তে হবে, বি বাই 2 এইচ বাই 2 centroid area, এটারও তাই হবে, একই হবে। ওকে, নাও xc is equal to for this area, say xc into a is equal to xc1, say for example this is say 1, this is 1, this is 2. Now what I am doing is, instead of this integration, if I know immediately for a particular shape, I know the centroid, then instead of integration I will apply the simple logic. So xc, so this is area 1 and this is area 2, xc1 area 1 plus xc2 area 2. How did I write that? You see, from this I can write that this, I can write, if I know the centroidal coordinate of this area, then I can write this as xc1 a1, this, I can write this as xc2 a2. So xc1 a1 plus xc2 a2 is equal to xc into a. Instead of this integration, I can write simply this. Since these are known and also these areas are known, I need not go for this calculation. So what is area is known. So now I will write simply, what is area? Total area 280 minus t square. What is A1? So this area. What is this area? 80. And what is A2? A minus T into D. A minus T into D. A minus T into D. Is it clear to everyone? Clear? Now what is xc1? Say for example xc1. What is xc1? What is xc2? So the integration for pattern integration tool. I know this. I know. For a rectangular area it is known. I will not integrate. For this is a by 2. A by 2. এটা এই আছে, আমি একটা एग्जांपल দিচ্ছি। এখানে x1 a/2 x2 কোথায় t/2 ক্লিয়ার t/2 কেন হচ্ছে? কারণ আমরা সব কিছু এই লেন্থে মেজার করছি, এই পয়েন্ট t/2। therefore xc is equal to 1 by a xc1 a1 xc1 a by 2 a1 a1 হচ্ছে 80 প্লাস xc2 xc2 হচ্ছে t/2 into a2 a2 হচ্ছে a minus t to t, right? So what is that? 1 by a square t by 2 plus a t square by 2 minus a t square by 2 minus t t cube by 3 t cube by 2 তাই তো ছিল এখানে a square t by 2 plus a t square by 2 minus t cube by 2. That's so the same as this. So it is basically t by 2 a into a plus t minus t square xc. Similarly, this is yc. Yc is also same. T by 2a I need not, because this is symmetrical, so I need not calculate. Clear? চার ইন্টিগ্রেশন করতে লাগবে না, সিম্পলিফিকেশন লাগবে, ঠিক আছে? হ্যাঁ, এটা সমস্যা আছে কেন হবে? হ্যাঁ, একদম। If you can determine for a triangle, if you can determine for a triangle, say for example, you have a triangle. If you have a triangle here, if you have a triangle here, then you can determine there will be another x3 a3. So for this there will be another x3 a3. Okay, for this it will be x c a is equal to xc1 a1 plus xc2 a2 plus xc3 a3. Actually, for n number of composite objects, n number of simple objects, when it is in a composite diagram, composite area, then we have xci ai. I is equal to, say for example, 1 to n. So x c a, any area, you can have any, okay, you can have any area. What you have to do is you have to decompose this. It is a composite. Now you have to decompose this into simpler objects, known objects. Say for example, circle or rectangle or triangle, simple objects for which you know easily, right? Clear? Right? Symmetrical eye section. If you have say eye, I will put it. You will have three rectangles. সেটাও করতে পারি আর একটা দেখিয়ে দিচ্ছি দুভাবে দেখিয়ে দিচ্ছি বুঝছে you see that you can do this problem by this is superposition. We are using superposition. Now instead of addition, hey follow, instead of addition you can subtract also. Say for example you have this area, this L is this plus this. Instead of that you can consider this whole area as this minus this, so it will be coming as minus, and then it will be more easy, it will be easier, it will be easier, right? It may be easy, it may be easier, right? So I give you assignment, this one. So solve as minus. So instead of plus, one will be say this minus this. So a minus sign will come. Clear? So you solve this as assignment. Done this? Now I got it. The class is check. To teacher. Regarding that will check. আধা ঘন্টা রাখতে হবে পরীক্ষার সময় প্র্যাকটিস করতে হবে অনেক প্র্যাকটিস করতে হবে সব থেকে সহজে কিভাবে করা যায় সেটা প্র্যাকটিস করতে হবে ওটা থাকতে পারে it may be that it needs rigorous calculation, but many times you can do smartly. Okay, so you see that for I, this is I, this is the section, I section. Have you seen I? Well, no. I in real life, beam, railway track, I section. একটু কম ছোট উপরে দিকে I section. Okay. So you see, I have to determine I because this is necessary for calculation of say bending moment, diagram bending stress, etc. So that is necessary. These are all area moment of inertia that we are calculating. Okay, mass moment of inertia. This is not under rotation. This is under bending because beams are under bending. So these are this. This is the same simple I section. It is not having this top and bottom. These flanges are not there. Okay, so you can take 1, 2, 3. You can split this like this. So A1, A2, A3. You can do like this, right? You can easily calculate. Say for example, this is given as say T. T means thickness, and this is say A. Okay. So this is also say A or say B. This is T, this is T, this is T, all T. T. You can determine by simply because you know the centroid of the rectangle. So you can determine. Acha, in the last problem I missed the moment of inertia calculation. Moment of inertia calculation will be also similar. Exactly similar. So in that case, basically instead of xc, you have basically I. So what is I? I is x square. I'm sorry. Say iy. I x will be y square d over there. Y square d. Then I will take that element. I will put that dA. I will put that dA. dA is x prime y dy. So it will be y square into x prime dy 0 to t plus y square x prime dy t to a in the last problem. So 0 to t what time? Now what about? Okay, so it will be basically is equal to I1 plus I2. I is equal to I1 plus I. This you know. For 0 to t, you know what is x prime? 0 to a. X prime is a by. X prime is a by.